Hi everyone, in this video we're looking at volume of composite shape. So by the end of the lesson you'll be able to calculate the volume of a composite shape, and you would do that by identifying and deconstructing the shape into its basic components, modifying your volume formulas, substituting appropriately and correctly, and then stating your answer in the appropriate units. Also, remember that there is a relationship between volume, which is centimeters cubed, meters cubed, kilometers cubed, and capacity, which is like milliliters and liters. So you've got your formulas there that you're using, and in this lesson we're essentially modifying them to represent our composite shapes that we are looking at. So modify the formulas if you are required. Now, to calculate the volume, generally it's a little bit easier than surface area, because you're actually just either adding two volumes together or multiple volumes together, or subtracting one volume away from another. So it doesn't require as much like spatial thinking as surface area. So here we go, we've got a shape here. Calculate the volume of these shapes. So we can see that we've got a pyramid on the top, and this is actually a cube, so that makes our life a little bit easier. So once we've identified our two shapes, we can just write a formula for it. So total volume equals length cubed, because that's the volume formula for a cube, plus 1/3 of AH. So total volume equals 10 to the power of 3 plus, now at base of this pyramid is 10 by 10, so that's going to be 10 squared times the height, which is 12 here, and I'm going to divide that by 3, and that gives us a total volume of 14,000 centimeters cubed. Now there's nothing stopping you from doing the pyramid separately, so like volume of pyramid equals, and doing that one and doing your F, S and your A of 400 centimeters cubed, and then doing your volume of your cube is 3,000 that's cubed, and then TV equals volume B plus volume C. So you could do it that way as well. I just prefer to do it these ways because it's something I can just plug into my calculator in one big time, especially when you've got problems like the one that we're about to do with pi, because they've got lots of decimals in it. So just trying to avoid that repeated rounding, which causes errors in your calculations. So here's our second shape. We can break that down into a cone, and the radius of that cone is going to be here, so that's 3 centimeters. We've got a hemisphere, which is half a circle. So whatever we're going to do, we're going to take our pi, r squared, and divide that by 2. You're like wondering, well, the radius is consistent all the way around, so that's going to be 3 centimeters there as well. And the last one is your cylinder here, and that's going to be pi r squared times height. Now you're probably wondering, where is the height coming from? This is 5, so we can subtract from 16, we can subtract 5 plus our hemisphere. So our radius is, regardless, from the center point always outside to the circle, and it's the same in a 3D shape. So that's going to be 5 plus 3, which equals 8. So that cylinder height is actually 8 centimeters. So now that we've got that information, we can go total volume equals. Now I'm going to do the cylinder as it is. pi r squared h. So I'm just going to call that, actually, no, I can do all the same because everyone's got the same radius, plus our cone, which is going to be pi r squared. Oh no, sorry, I do need a different h. I'm going to call it h1, h2, and dividing that by 3 because it's 1/3, plus pi r squared. Oh, sorry, nope. It's going to be 4/3 times pi r cubed, and then we're going to also multiply that by 0.5, and that's just the same as saying divide it by 2. So that gives us our formula for what we need for total volume. Now, if you wanted to, you could like substitute and break down each component, so you could have like substitution, the answer, and the separate calculations, and then the answer. But I'm just going to go straight from substitution and then answer because my calculator is doing all the heavy lifting. So for the cylinder, we've got pi times r, which is 3 times and 8, our height of our cylinder, r squared, plus times 3 squared times 5, because that's the height of our cone, divided by 3, plus 4 times pi times 3 cubed, and 0.5, and divided by 3, and the answer is going to be 329.87 centimeters cubed. Alright, so that's composite shapes. Remember, identify what shapes you have, adjust and modify your formulas if you would like to do just one big formula, substitute appropriate values, and make sure that your answer responds in the appropriate units. Alright, thank you everyone. Bye.